In today's lesson, we're going to be looking at solving linear equations with brackets on both sides, or more importantly, solving linear equations with variables on both sides, and we're also going to have brackets on both sides. So that means it's looking like the distributive property on both sides. So let's start off here with my first question to show you what I mean. We're going to have 2 multiplied by 2x plus 6 is equal to 6 multiplied by 13 minus 3x. Okay? So, we're looking at this here. It's saying I have 2 groups of 2x plus 6 on this side and 6 groups of 13 minus 3x on that side. So if I have 2 groups of something, remember the balance we were looking at earlier? I have 2 groups on one thing and 6 groups on the other. Why don't we just make it so it's 1 group and 3 groups? It's still the same ratio and would be equally balanced. 2 groups and 6 groups compared to 1 group and 3 groups is the same ratio. A way of looking at this is to figure out if we can do that is, do they have a common factor? 2 and 6. Both of these could be divided by 2. So I'm going to half both of these. And that still keeps my balance. And that allows me, so I don't have to use the distributive property on this side, and I'm only using the distributive property on one side. It's a neat little trick to kind of half your work a bit there. So these 2's are going to cancel out, because 2 divided by 2 is 1, and 6 divided by 2 is 3. So I am left with 2x plus 6 is equal to 3 multiplied by 13 minus 3x. Alright? Now I look at this, we have 1 group, or just 2x plus 6 on this side, and we have 3 groups of 13 minus 3x. So we have 3 groups of 13 of these singles, and 3 groups of 3 of these x's. So that means we have to use my distributive property and multiply this in to both. So I'm going to end up here now with 2x plus 6 is equal to 39, 3 times 13 is 39, minus 9x. Okay? Now, we have these on both sides. We have x's on both sides. We want x's on only one side. So I'm going to take the side where x's is the biggest, or the biggest positive or closer to positive. In this case, it is this 2x. Right here, we have a positive x, here we have a negative x. So if we remember back to the boys and girls, right here, boys are negative. So how do we get rid of a negative? Well, we're going to add a positive. So we have 9 boys, and we're going to add 9 girls. That means there's no boys left. Every boy has a partner, and every girl has a partner, and there's no one left at the punch table. So I'm going to add 9 on this side. So what I do to one side, I must do to the other side. So these will cancel off to give me 0, and I'm going to have 11x on this side plus 6 is equal to 39. Now, we're going to continue this here. I have 6 there. I want to get rid of that 6. There are 6 girls here, so I'm going to add 6 boys. Negatives are boys, right? What I do to one side, I must do to the other side. Here there are 39 girls without a partner. I'm going to add 6 boys. So now, we're going to have 11x is equal to 39 minus 6 is 33. Because if we think about it, if there's 39 girls without a dance partner and 6 boys show up to the dance, that means we're now only going to have 33 without a partner. Okay? Now I look at this, we have 11 of something is equal to 33. So we divide both sides by 11, and I get x is equal to 3. And that's how we get my answer. Okay? So we're going to look at one more example here. One that's a little bit trickier. All right? So let's take a look at this next one. For this next one here, we are going to have 3 groups of 7 minus x is equal to 2 groups of 3x minus 12. Okay? So if I'm looking at this one here, it's not like the one above. The one above, we had 2 groups and 6 groups. Well, if we look at 2 groups on 6 groups, 2 on one side, 6 on the other, we could balance it out by saying that's the same as 1 and 3, right? We could half both. This one here, we can't simplify in such a way. We cannot find a common factor between 3 and 2. And since there isn't a common factor between 3 and 2, we have to use our distributive property to multiply them out. So to get rid of the brackets in this case, we're going to have to use my distributive property. So 3 times 7 will give me 21. Then we're going to go 3 times negative x is going to give me negative 3x. Now this one here, we're going to go 2 times 3 is 6. And then 2 times negative 12 is negative, oops, this should have an x. That was 3x, I believe. Yep, 6x. And then 2 times negative 12 is negative 24. All right, so now we have to balance it out here. We have x's on both sides. First of all, we want x's only on one side. All right? So I'm going to look at this here. This is positive, this one's negative. So we're going to try and get rid of our negative, move it to the positive side. So we have negative 3, that's like boys. If we have boys without a partner, we need to add 3 girls to the dance in order for the boys to have a partner. Okay? So now we have all my x's on one side. So I have 21 is equal to 9x minus 24. Now we have to get all of my singles, all my units, my ones on the other side. So I have 24 boys here without a partner. I'm going to add 24 girls to the dance, and now everybody has a partner. But what we do to one side must do to the other. Okay? So that's going to give me here 45 is equal to 9x. Now if I have 9 of something is equal to 45, or 9, I don't know, popsicles is equal to $45, well, what is going to be the value of the popsicle? Well, we would divide this by 9 and divide that by 9. So I end up with 5 is equal to x. And that is my final solution. So just as a quick review, when there's brackets on both sides, first thing we want to do is get rid of the brackets. The easiest way of doing that, if the numbers, and keep your numbers low so you're not working with too big of numbers, is to find the common factors of our coefficients in front of the brackets and divide by the common factors. Okay? If we cannot do that, then we have to go straight to the distributive property and multiply in our coefficients in front of the brackets to each term in the brackets. After that, we're just going to solve like we normally do, and that's all there is to it.